This is a tutorial on how to use the z-test for one sample in Excel using the Data Analysis Toolpak. So we have here the sample problem. A civil engineering company claims its concrete mix has a mean compressive strength of 30 megapascals. You randomly sample 40 concrete cylinders and test their strengths. You want to test if the actual mean strength differs from 30 megapascals. So that is the standard of the civil engineering company. The population standard deviation is known to be 0.6 megapascal. Use a level of significance equal to 0.05. So we are given the compressive strength set by the civil engineering company. So that is the hypothesized mean. Which is equal to 30 megapascals. So we have a 40 concrete samples, so that is our N. Then we want to test if the actual mean of the samples differs from the hypothesized mean. So we are also given the population standard deviation. So that is our clue that we can use the z-test. So take note that we can only use the z-test if we are given the population standard deviation or the population variance. But if we do not have the population standard deviation or the population variance, we can't use the z-test. Instead, we can use the t-test. So the population standard deviation is 0.6 megapascals. So I will solve the population variance because we need this later on for the z-test using the Data Analysis Toolpak. So variance is the square of the standard deviation. So we will just square this one. So raised to 2. So that is the variance. And we are also given the level of significance or the alpha. Level of significance 0.05, or this is also equal to 5%. So if the level of significance stated in the problem is 10%, use alpha 0.1. If it's 1%, then the alpha should be 0.01. So next is to write the null and the alternative hypothesis. So the null hypothesis is the HO. So null, if we say null hypothesis, that is the hypothesis where there is no significant difference between this hypothesized mean and the samples, or the hypothesized mean is equal to the sample. So we can write this simply as the sample mean, the compressive strength of the sample mean. So if you want to complete that, the compressive strength of the sample mean is equal to the hypothesized, which is 30 megapascal. So for the alternative, that is the negation of the null, so we can write it based on the question or the test that we want to do. So we want to test it if the actual mean strength differs. So we only want if there is difference. We are looking for the direction of the alternative, meaning we do not want if it's greater than or it increases or decreases. So we just want to know if there is difference. So we can write that as the compressive strength of the sample mean is not equal to 30 megapascal. So that is the alternative, not equal. So if we use the inequality not equal, this test is a two-tailed test. So it is important to identify if the test is two-tailed or one-tailed because our critical values depend on this. So next, if we have already written the hypothesis, we are going now to solve for the z value because this is under the z test. So we will use the Data Analysis Toolpak in Excel, but take note that the Data Analysis Toolpak offered by the Excel can only solve for z-test for 2 samples. But this problem is for 1 sample only. Why? Because the data given, so the 40 compressive strength of the different concrete samples or concrete cylinders came from a civil engineering company. One civil engineering company only. So it is for one sample test only. But if the problem states that there are different companies giving the two different batches of concrete samples, then that is for 2 samples. But this problem has only one civil engineering company, so this is a 1 sample test. So in order to use the analysis toolpak of the Excel, we will introduce dummy data for the second sample. So we will rewrite or copy the different samples of the 40 cylinders. So these are the compressive strengths of the samples in a single column. So we will just retype it, or you can copy it in a single column. So you can use any column in your Excel. So this is the last one. So there are 40. So 40 data because this is 40 sample. So the column beside it, we can just type on 00 because it's a dummy data. So we just want a second column for the data analysis toolpak. Next, we will go to the data, then data analysis. So before that, make sure that your Excel has the data analysis. So click on the data analysis, then we choose on the z-test, so it is at the last part. So you can see here that there is only the 2 sample for means, so we needed to introduce dummy data. So click on that z-test, then a dialog box will appear. So for the variable 1 range, highlight all the data from the civil engineering company. So there should be 40 datas. Then for the variable 2 range, we will highlight the 2 dummy data. For the hypothesized mean difference, so we want to compare the sample in their standard, which is the 30 megapascal. So we will type on the 30 megapascal. For the variable 1 variance, so known, so there should be the variance or the population variance of the data, and it is stated on the problem, so that is 0.36. We are given the 0.6 standard deviation, but from that standard deviation, we can solve the variance by squaring it. So the variance is 0.36. For the variable 2 variance, so that is the variance of the dummy data. So the variance should be 0, but the Excel won't accept a variance equal to 0. So what we will do is to introduce a very, very small number. So we can write 1 times 10 raised to negative 99, or that is 1e negative 99. So for the labels, I will not check this because I did not put any labels before the data. For the alpha, so the default is 0.05 and our level of significance is also 0.05, so I will not change this. But if the given level of significance is 10%, you need to change this to 0.1. So we are good with the alpha. For the output range, so where you want to see your result. So I will just click on any blank cell, then OK. So we will wait for the result. So here is the result of the z-test. So we can see from the title of the z-test that it is for 2 samples, but we just introduce a dummy data, so we will just edit this for 1 sample. coming from the civil engineering company. Then for the variable 2, we can delete this because it is a dummy data. So we will be left with this one. So for the mean, that is the average of the 40 concrete cylinders, the known variance, so that is what we have inputted. Then for the observations, we have a total of 40 concrete cylinders. For the hypothesized mean, so that is the standard of the civil engineering company where we compare the samples. Then this is the z-value or the z-stat. So that is the computed z-score of the different samples. Then this critical, so we have here the probability for one tail, the z critical for one tail, the probability for two tail, and the z critical for two tail. So it is important to identify if this is two-tailed test or one-tailed. So we have identified before that this is a two-tailed test, so we will choose the z critical for the two-tailed test. So this is the z critical for the two-tailed test. So meaning, we will compare the computed z-value with the z-critical for two-tailed. So if we will check this with the figure or the bell curve, it will look like this. So our z-critical for two-tailed, so that is automatic positive and negative because it is two-tailed. For the z-value, it is 0.7906, so it is here, yung red line. So we can observe that the z computed falls under the unshaded part. So using the critical region, we can decide that, so the decision based on the z critical and the z computed is we do not reject the null hypothesis because the z-value, which is 0.7906, falls to the unshaded part, meaning we do not reject the HO. But if the z-value falls under the critical regions, here at the blue shaded, we reject the HO. So the decision for this test is to not reject the HO. So for our conclusion, because we do not reject the null hypothesis, there is no significant difference between the sample mean and the claim population mean or the hypothesized mean of 30 megapascal. So that is our conclusion. If we use the z-value and the z-critical. Also, we can use the alpha. If you want to use the alpha, which is 0.05, we will compare this with the probability or the p-value. So that is the probability for two-tailed. So if your probability computed is greater than the alpha, we do not reject HO. So take note, if the p-value is greater than the alpha, we do not reject HO, which is the same as our decision. Here is another example for z-test 1 sample. A civil engineering firm claims its standard concrete mix has a mean compressive strength of 30 megapascal, so that is the same as the hypothesized mean of the previous problem. To test a new concrete mix, a sample of 40 concrete cylinders is tested and their average strength is 30.6 megapascal. The population standard deviation is known to be 0.8 megapascal. At a 5% level of significance, is the new mix significantly stronger than the standard? So that is the question we need to answer by hypothesis testing. So we have the hypothesized mean, which is 30 megapascals. Then we are given a total of 40 concrete cylinders, so that is our N. And their average strength, so given here is the average strength of the 40 samples. We do not need to compute for the mean. So we are not given, so if you will compare, we are not given the different compressive strengths of the 40 samples. But the problem already gave us the mean of those 40 samples. So that is the sample mean, which is equal to 30.6 megapascals. And the population standard deviation is 0.8 megapascals. So the population variance, so we need this later on, so we need to compute for it, is the square of the standard deviation. So we will just square that. So we have 0.64. And our level of significance is 5%. So that is 0.05. So same as the previous problem. So the previous problem, we have copied the different compressive strengths of the sample in a single column. But for this example, we are already given the mean of those 40 samples. But the Excel, so the analysis toolpak, can't do the test if we are already given the sample mean. So because we need to input the different datas for the 40 samples. But for this problem, the mean is already given. So we just want to make sure that the data analysis will read 40 samples. So what we will going to do is to input the 30.6 sample mean 40 times. So by doing this, we have given the Excel a 40 samples. So if we will get the mean or the average of these 40 samples, it is also equal to 30.6 megapascal. So before we go with the test, let's write first the HO and the H1, or the null hypothesis and the alternative hypothesis. So for the null hypothesis, that is always no significant difference. So this is the sample mean, or the compressive strength of the sample mean is equal to 30 megapascal. So for the alternative, so the question, we will read again the question. So at the 5% level of significance, is the new mix significantly stronger? So it uses the word stronger. So that is a directional alternative hypothesis. So meaning we will not use the not equal inequality. So we will use the greater than, because we want to know if the sample mean is greater than the stronger, or is it stronger than the standard. So instead of not equal, the compressive strength of the sample mean is greater than 30 megapascal. So that will be our alternative hypothesis. So if that is our alternative, this is a one-tailed test. So take note, if it's two-tailed, we use the word not equal. But for one-tailed, it is either greater than, increases, stronger than, weaker than, or decreases. So we already have the 40 samples with the 30.6 megapascal. So this is a one sample test. So we need to introduce a dummy data again. Then we go to the data analysis choose for the Z test. Click on OK. So here is the dialog box. So we need to input the data needed. So for the variable 1 range, we will highlight all the 40 datas. Then for the variable 2 range, that is the dummy data. So it is like the previous problem. For the hypothesized mean difference, so we need to input the standard of the company, which is 30 megapascal. For the variable 1 variance, so that is the computed one from the standard deviation, which is 0.64. For the variable 2 variance, so this is a dummy data again, so we need to input the smallest possible number. For the label, so I will not check this because we did not write any labels before the data. For the alpha, so I will not change this because we have here 5% level of significance, so that is the same as 0.05. Then for the output range, so we can choose any blank cell. Then OK. So we are again given the result. So we will just edit this because this is for one sample. Then delete the last column. So the Z computed, from here the mean is 30.6, so that is the given, so we did not change it. Then for the variance, that is 0.64. Then we have 40 observations, so the hypothesized mean, that is 30 megapascal. And for the computed Z value or the Z test, that is 4.7434. Then we have here the P value for one tail, Z critical for one tail, P value for the two-tailed, and Z critical for the two-tailed. So we will choose the Z critical for one tail because we have already identified before that this is a one-tailed test. So we only have the critical value at the right tail because it is a positive value. So if we will check the curve for this one, so this is the curve. So the Z critical, this is the same as the 1.645, so same here, the blue shaded part. So starting from 1.645 going to the right, that is the critical region. So any Z score that will fall on that will reject the HO. And if we will check, the Z value computed is equal to 4.74, which is at the rightmost of the at the right part of the curve. So by checking the bell curve, the Z value falls at the critical region. So the decision here is reject HO. So if we reject the HO, our conclusion will be, so we rejected the HO, meaning there is significant difference between the sample and the standard, or because the question is asking if the new mix significantly stronger, so we will conclude that the new mix is significantly stronger than the standard. So if you want to use the alpha again, so our alpha is 0.05. So if you want to use the alpha, compare it with the P value. So the P value that is for one tail, which is 1.5 times 10 raised to negative 6. So that is less than the alpha value. So if the alpha value is if the P value is less than the alpha, we reject HO. So same as our decision when we use the z value. So those are the sample problems on how to use z-test for one sample in Excel using the data analysis.